Okay, before the semester break, we already covered lecture 11. I went through the AOA diagram, the whole concept of example, including how to draw the diagram, how to basically run the CPM on that diagram in order to get all the values, early start, early finish, late start, late finish, total float, and including the free float. And then we can identify the critical path and so forth. Okay, so it was a complete calculation method for the arrow diagram. So now the last topic for the CLO2. Slide number, I name it slide number 12A because there are two parts, 12A and 12B. So 12A is basically just introduce the concept of AON and then precedent diagram method. We already introduced the concept during the network diagram anyway, but this is just a revision, okay, so that you understand the critical path method is the mathematical computation that we can apply on different type of diagramming techniques, namely arrow diagram and AON and subsequently PDM. Now, for instance, we might not call AON anymore because once you say PDM, automatically AON already included in that kind of technique anyway. All right. So critical path method is the concept, mathematical computation in order to get the critical path. For instance, it was being developed way back in 1950s by US Navy. See, this kind of thing was developed technically by competent person. Okay, by competent person meaning to say they are the people who are well versed in technical know-how, and they come up with a technique in order to help them solving the real issues. Okay, and then what else? So again, if you still remember, we mentioned about the bar chart. Bar chart was being developed way back in 1910 in Reagan, and then 1950s come the CPM, and then we do have what we call the concept of AON diagram, AOA diagram, okay, AOA diagram, and then subsequently this what we call okay, let me mute all. All right. AOA diagram and then subsequently PERT diagram. And 1960s, early 1960s, AON was being developed, and in the middle of 1960s, PDM was introduced. PDM basically was the enhanced version of AON anyway. The differences between AON, the normal, the just simplified version of AON with the PDM diagram is just this concept. They do have different type of relationship, okay? They do have different type of relationship. For instance, other than FS, finish to start. This is just a typical relationship. But then when we are talking about other relationship, other than FS, plus lag. Remember, lag can be positive and then negative. So when we incorporate this thing, so this is what PDM is all about, okay? The essential technique for using CPM, critical path method, of course, in order to be incorporated into the network diagram, we need to have list of activities, or we call it tasks. Where do we get this thing? From our WBS, work breakdown structure. Remember, we learned at the earlier CLO concept. Normally, when we get a drawing for a project, especially for contractors, so contractors need to study those things and then break up the whole entire project into a smaller activity or basically tasks. And those kind of tasks will eventually become the listing, a list of activity or list of tasks that we put into our what we call entire scheduling. All right, then we need to come up with the duration. Where do we get this duration from? Again, from the concept of productivity rate. Remember last time I gave you this very simple formula. Productivity is equivalent to output per input, output in terms of quantity, and then input in terms of time. Okay, so from this concept, so the duration is being derived from the time equation there. Okay, once we have the productivity rate of any task here, and of course we can calculate the quantity. Either it could be coming from our bill of quantities, or we can even, as an engineer, for instance, we have learned how to do the taking off. Okay, taking off is the concept of estimate the some duration, some quantity of certain tasks. But in scheduling, for instance, we do not want the entire quantity. We need the smaller part, because scheduling is being done part by part, not the entire things. Sometimes in the bill of quantities, they give you the entire quantity of what we call slab, for instance. Whereas in the real construction, we are not going to cast the slab in one go, for instance. We're just basically going to split the slab into section, isn't it? That is more practical. But then we need to basically estimate how much the quantity of certain portion. So again, we need to use the technique of taking off. The dependency, this is what we mean by relationship between one activities and another. And then we can even overlap the activity, or we can basically drag the subsequent activity a little bit far away instead of immediately, in order to allow for some kind of delay. For instance, we want to put in between such activity curing time, for instance. That is a classic example of lag that we can incorporate into the relationship. Okay, so the CPM basically calculate the longest path. Okay, the longest path. Once we input the early start and early finish values, at the end of the day, the last values on the, for instance, the forward pass will be the overall project completion, which basically come from the lowest and the longest path. Okay, and of course the critical activities are going to be connected together, and they are going to be called critical activities, whereas the rest of the activity might be classified as non-critical. Non-critical meaning to say they basically do have some free time that they can be delayed, or they can be adjusted in a simple layman term. Okay, whereas the critical activities are normally activities that do not have any total float values, meaning to say total float value is equivalent to 0, and they cannot be delayed or adjusted in any way. Once you adjust the timing, automatically the project completion will be adjusted as well. Okay, this concept, strategy, we are going to learn this thing in the subsequent topic, CLO3. We are going to start those things next week anyway. In project time cost trade-off, for instance, or in simple terminology, we call it project crashing. Let's say we are running short of time. We are experiencing delays at the beginning of the project, for instance, and the remaining, basically, we need to speed up. How do we speed up? Okay. How do we speed up? How basically we shorten the remaining things by putting by adjusting, for instance, the duration of activity instead of one activity, let's say activity G equivalent to 10 days. Instead of sticking to the same 10 days, we might basically want to slash into 8 days, for instance. Okay, but adjusting those duration does not simply mean erase those things on in the computer. That's it. It is not as simple as that. We need to go back to the fundamental. How do we get the duration from? It has something to do with the resources that we already calculated. So meaning to say, we need to adjust the resources. We need to assign more resources. It could be manpower, it could be machine. We need to basically use the technology, precast concrete, for instance, or IBS, that we can quickly install. We can even, for instance, change the calendar. Instead of putting 5 days per week as working days, working time, why don't we adjust, we add another one more day. For instance, Saturday is a working day as well. If we are really running short of time, even people will work on the Sunday. Why not? Okay. Let's say we do have holidays, many public holidays that we incorporated into our calendar, which is sometimes not necessary. Under Malaysian law, for instance, there are only a few mandatory public holidays, okay? Public holiday, mandatory. So meaning to say, if, for instance, you want people to work on that particular day, you need to pay extra anyway. The rest depend on organization, whether they want to take up that holiday as well. But if, for instance, you are running short, why basically you use that public holidays, for instance, but of course you need to pay money. So that is what project time cost relationship is all about. Sometimes you want things fast, but you are going to sacrifice on additional costs. That is a very common sense anyway. To start, you start to start relationship. If, for instance, you use start to start relationship between two different activities, what does this thing imply? You cannot use the same workforce, isn't it? You need to use different team. Then only you can utilize this. Then additional cost will be imposed, of course. But then you can cut short the time. So those kind of things. And divided long activity into the shorter one. Sometimes your bar chart could be this long. And after this bar chart, then only you are going to be connected with subsequent activities. And this imply you need to complete all these long activity, then only this activity can be started. Sometimes it's not necessary that way. Let's split that one into a few parts. For instance, you completed this part, okay, and then some part of this activity can be completed. That is much what we call common sense, instead of putting the activity in such a long bar, for instance, in anticipation of nothing happen, but in reality, delay could happen in between. That is the issue. So that's why critical path is a tool that we can use so that we can see what could be the impact to the subsequent activities so that we can come up with the strategy. Okay, there are a few strategies which we are going to apply into our subsequent topic anyway. But since it is here, so I might as well go very brief. Okay, benefit of critical path, again, allow continuous monitoring of the schedule. Once we know what is happening, what impact such activity have on the subsequent activity or even on the project completion, that basically will give us ample time to react, okay? Because we can see the schedule even before we start the project. That is what we call plan, okay? How much time we do have in between, that is what we call free float. If we know such activity are very tight, meaning to say they do not have very much free float, we need to be very careful not to basically delay such activity a lot, because at the end of the day, it will create another critical path. Instead of having one critical path, then we are going to have two critical paths, three critical paths, and subsequently, we notice that we are going to get stuck because we do not have plenty of time left, because every activity are now cannot be delayed. That is the issue. So project management software, we already mentioned, there are hundred of popular software around, maybe more than 200 software. So at the end of the day, which software do we use? For me, it is very simple. Simple evaluation. Use most popular software in that particular country. If, for instance, some of you are international student, and you go back to your country, maybe in your country will use different kind of software, never mind. So you basically adopt that kind of software, because whatever software that people use, you need to share the file between many parties or stakeholders. So if, for instance, you use software that the only one that have or purchase, then how are the other parties going to open? You cannot basically give them the PDF version, because sometimes it is very small. Sometimes you cannot print all. And then sometimes you want to simulate, for instance, whatever happened to certain changes, how the impact will be, that kind of thing that you want to see. So software will give you the quick solution. So go for the popular software. Okay, these are the typical relationship that we use for PDM diagram. Remember, finish to start, we use in AOA diagram only. And actually, when AON was being invented, basically AON also used finish to start relationship initially. But then when PDM come into this picture, PDM have the ability to basically incorporate many more type of relationship, including the lag and lead. Okay, including the lag and lead. Okay, for instance, again, this is just a revision. We already covered the relationship many times already. Let's say finish to start relationship. This is a typical, we can reflect this thing as the bar chart or even AON or PDM diagram. If it is bar chart, so again, the left side of the bar reflects start. The right side of the bar reflect finish. Always like that. Or if, for instance, we assume this is the box for activity on note or PDM diagram, again, the left side of the bar, the left side of the box reflects start. The right side of the box reflects finish. So again, on the other box, for instance, it repeats the same concept, start to finish. And you notice that once we do have arrow connected from another side, one side of the box into the other side of the box, in this case, it is clearly indicated that the bar is coming from this, the right-hand side, which means F, and then connected into the subsequent box on the left-hand side. So this is what finish to start relationship is all about. Okay. So finish to start relationship is very straightforward relationship, and most of activity do have this kind of typical relationship. But again, if we only use finish to start relationship like this, for instance, all the activity is like this. At the end of the day, so meaning to say we are going to have a long project completion period, which we might not afford to do so. Sometimes our contract has been locked at the beginning of the signing ceremony there, 2 years or 1 year. So basically, everything must fit within the contract period. So what are you going to do? So you need to utilize different type of relationship, and you need to utilize lead, for instance, overlap between two activities in order all those activities to be fit within the contractual period. Okay, start to start relationship. Start to start relationship. Okay, so meaning to say two activities start at the same time. Example, cutting and filling. This is very typical. In earthwork, for instance, cutting and filling is always the activity that work together, hand in hand. Because when you cut certain portion of the soil, for instance, you are going to dump those things into the filling area. As simple as that. So that's why cutting and filling is a classic example of start-to-start relationship. On the other way around, cutting and filling also can be connected finish to finish, the same activity. So what is the differences between start to start and finish to finish? Because the activity looks the same. Well, this is just to emphasize which one is more important. Is it the starting of such activity or the ending? There are some activity connected together, but for instance, cutting and filling. Normally, the cutting will require a longer time compared to filling. Filling, basically, you just use the bulldozer and basically push the soil into this filling area. But cutting, you need to basically use a lot more energy. So it could be, it require longer time. Okay. So cutting must start earlier. Cutting might start earlier, for instance, in this particular case. And then later on, filling will follow suit. Okay. But whatever it is, this activity has to be completed at the same time, because, for instance, you are going to connect with another activity. This activity, for instance, let's say grading. You want to put some kind of leveling on the soil, for instance. And of course, when you want to level the soil, so this activity must be completed. Otherwise, you cannot start. This is an example. So the differences between start to start and finish to finish, even though they look the same in terms of the activities, but this is just to emphasize, okay, which one is more important, the starting timing or the ending timing. In this particular example, cutting can start much earlier, whereas filling will follow suit, but at the end of the day, both activities should be completed. Okay, should be completed at the same time so that grading can be started. That is the concept. But whatever it is, start to start or finish to finish relationship will influence the calculation in our network diagram. Later on, we will see how basically those kind of relationship will influence. And then lastly, start to finish. Start to finish is basically is a very rare type of relationship, but I have seen the real people, the real project manager basically use. Even my previous student, okay, from UTM, for instance, graduated, he basically used start to finish relationship. Well, instead of using start to finish, we can use finish to start. It is the same thing. It is just on the other way around. But again, this is to emphasize the importance of something. Okay, let's take a look at this example. What is this activity? Bricklaying. Bricklaying. Let's say we want to construct the wall, column, whatever structure using bricks. In Malaysia, we really uh, install the what we call the structure using brick, but in other countries they like to do that. Okay, for instance, the starting of laying brick cannot be start before brick being delivered. You see, this is start to finish type of relationship. If you want to start something, the whatever the activity, the previous activity must be completed. This is a example of start to finish relationship. Okay, how about starting of the brick delivery? The start of brick delivery cannot be done unless procurement completed. What is procurement? Procurement is the process of purchasing. Okay, you need to basically put an order, approval, getting approval, and submit those kind of things. That is what we call procurement. And until those process completed, then only brick can be delivered. Okay, the procurement can be started after sample being approved. If, for instance, the sample that we already sent to the consultant not being approved yet, the completion process is not there yet, then basically we cannot start the procurement. And then the last one, to start the sample approval process, of course, sample have to be submitted. After you submit those sample, then only sample can be approved. And that is the logical part of the relationship. But again, as I mentioned to you, this is a rare kind of relationship. Instead of breaking the head, coming out with all the thing in reverse, you can do the other way around. For instance, finish to start, very straightforward. But again, this is to emphasize. We can use this kind of relationship in order to come up with the procurement schedule. This is what we call procurement schedule. And then we can basically use this concept in the quality assurance flowchart. And as I mentioned to you before, a classic example of two activities. Let's say this is the river, okay? This is the old bridge, which is still running, okay? People can still use this old bridge. At the same time, they are constructing a new bridge. Then come two activities. For instance, demolition, old bridge. Let's say you want to start demolish the old bridge. When can you start? See, this is the example that we can use. Finish new bridge. Finish the completion of the construction of new bridge. Mean to say here. That is the logic. You cannot start the demolition unless the new bridge completely completed. So this type of relationship is to emphasize the importance of the date. The other way around. This is a classic example. All right, now we go into lag and lead. Lag and lead. Okay, lag and lead. Okay, lag and lead. Start with the lag first. Okay. What is this? Okay, classic example, slab, poor slab. Let's say you do this flooring. Okay, one day you pour the concrete in, and then of course, this is multi-story building. After you complete the first floor slab, for instance, you want to construct the second floor slab, but you need to come up with the column, isn't it? And the column cannot be erected immediately when the slab is basically wet. So you need to wait to the waiting period, or we call it curing, for a few days. So in between, if you can see in between, let's say 3 days, we want to allow the waiting period in between pour slab completion. So this is the start, this is the finish. After we pour the slab finish, then we do not want to immediately erect the column. We want to have a waiting period of 3 days. So how do we incorporate this thing into this, what we call scheduling, what we call labeling, okay? So we put it like this, Fs plus 3. What is 3 is all about? 3 is this gap, 3 days. We can use 3 days, 3 weeks, 3 hours, whatever, okay? And after 3 days, then only a column will start being erected, okay? So let's say post slab will take 4 days. Column will take, let's say, 3 days, okay? Let's say 3 days. And when we do the calculation, of course, we are going to start with 0. Let's say it is 0. 0 plus 4 equivalent to 4. Okay. 4, we are going to add with these 3. Remember, the fourth pass, this is the calculation from left into the right. So 4 plus 3 equivalent to 7. So column will start on day number 7 after we incorporate this lag. Then 7 plus 3 will be 10. So we are going to complete the project in 10 days. Why? Basically, it is a little bit late. Why? Because we incorporate lag or delay in between activities. Okay? So remember, lag can be positive or lag can be negative. Sometimes the negative lag I would normally call lead instead of lag. This is the term that I normally use, but we can use positive lag or negative lag anyway. But negative lag is simply basically lead. Okay, we'll look at those things. So positive lag is basically the delay in between the ending of such activity, the previous activity, and then the starting of the subsequent activity. So this is the example. Okay, how about lead? How about lead? Okay, how about lead? This is example of lead. Lead meaning to say overlap between two activities. If you want to remember the term, negative lag, okay, negative lag means to say overlap, where let's say we have -2. What does -2 being referred to? Remember, when we draw the diagram, we are going to draw the diagram from the left into the right on piece of paper. Left, basically, we start from day number 1 of the project. And then subsequently, when we go to the right, the day of the project will be added up. Okay, that is the concept. So when it is negative, meaning to say we are going to go back. We are going to go back by how many days? 2 days. 2 days. So this is -2. And the starting of the subsequent activity basically is ahead in terms of what? In terms of the finishing of the first activity. Still remember, the first activity start and finish. So after site clearing basically finish, then the cutting will start, but not immediately. The cutting will start ahead of the finishing of the previous activity by 2 days. So this is what 2 days is all about. And we put it negative because it basically start ahead of the finishing, ahead of the finishing of the previous activity. That is what negative stand for. Okay, if it is positive, meaning to say it is being delayed 3 days after the finishing of such activity. So the reference point is basically you must read this -2 with respect to here, finishing. Okay, so it is ahead by how much days, whatever the dimension that you use. And at the end of the day, if we use the same calculation method, let's say site clearing is 4 days. Okay, 4 days. And then cutting is basically 4 days or so. Let's say 4 days. 4 days or so. So from the calculation, 0 plus 4 equivalent to 4. Then here, 4 plus -2. Remember in the fourth pass, we plus, but now since we do have negative, so the calculation will be 4 plus -2 will be 4 minus 2 will be 2. So now the cutting will start on day number 2, okay, instead of day number 4, and 2 plus 4 equivalent to 6. So we are going to complete on day number 6. Instead of, for instance, if we do not have any overlap, just simply finish to start relationship. 4 for the site clearing and 4 for the cutting will take 8 days. But now we managed to basically shorten a period a little bit. That is the usage of negative lag, or I normally call it lead. All right, then, okay, the rest of the example are about the same. Instead of using a different type relationship, now we use start to start. Start to start plus 5. Okay, so remember 5 days. 5 days basically is the delay. Delay from where? If we read back this one, delay from the starting of the previous activity. So this duration represent 5 days. Okay, so that is what? SS plus 5. If, for instance, we put it SS minus 5. SS minus 5. So meaning to say, the second activity would basically lead a little bit 5 days. 5 days is here in advance. But then it cannot be lay brick and plastering, which is not going to be logic. Okay, so we must basically use the activity which is logic. If we want to use start to start is -5, and we can use that in some of the previous final exam. For instance, we do incorporate that kind of things in order to demonstrate to the student we can do that. Okay, certain activities could be ahead of whatever the activities that we put on the previous one, but sometimes when we put activity in terms of A, B, C, D, E, F, people always thought that A will be the starting activity. But in reality, in real world, A basically does not mean the beginning activities, because we are going to use the real name of such activity anyway. But because we use ABC, then people got confused. If, for instance, we use this kind of relationship, SS minus 5, that is the issue. But it is possible, okay? It is just the calculation method anyway, okay? All right, then finish to finish. Okay, finish to finish with plus 5 days. So meaning to say this is FS plus 5. So remember, 5 days delay. What are the things that we are going to delay? We are going to delay the finishing. Okay, the finishing. This is the example. This one and this one. This is the period of 5 days of delay. If, for instance, we do not have the plus 5, we are going to draw the activity simply like this. See? So meaning to say they finish on the same date or same time. This is just simply finish to finish relationship. But if, for instance, we incorporate plus 5, so meaning to say the finishing of the second activity, meaning to say we are going to delay a little bit from the finishing of the first activity. That is the concept. Okay, that is the concept. Okay, how to do the calculation? Let's say, lay break is 10 days. Okay, lay break is 10 days and plastering is 5 days. Okay, from the calculation, 0 plus 10 equivalent to 10. All right. Then we are going to delay the subsequent activity by plus 5. By right, if you use this concept here, 0 plus 10, this is 5. 0 plus 10, this is 10. Okay. And the second activity, we are going to log the value of 10 here. We are going to log the value of 10, and this activity will start on day number 5. That is the concept, because we are going to log the finishing values. But now, in this diagram, for instance, okay, this diagram, 10 is here, okay? So 10 supposed to be here, but then since we do have plus 5, so it is going to plus 5. So it is going to be 15. So if it is 15, then when do plastering will basically start? So we minus back with 5 here. Then plastering will start on day number 10. 10 plus 5 equivalent to 15. So we log this value. That is the concept. So whatever it is, the type of relationship plus the lag, positive lag and negative lag, will influence the value that we input into this the box, PDM box. Previously, we might basically learn a very simple way of calculating. Just add early start plus duration, and then we get early finish, as simple as that. But now we need to consider various type of relationship plus lag and lead. And nowadays, in major software, basically use PDM more than any other method. So basically, you need to learn or understand this thing very well, because in reality, this is the method that will be used in most of the software. Okay, early start, early finish, late start, and late finish. We already mentioned in the second or third class, okay, about the terminology, because this terminology is coming from critical path method. And remember, critical path method, we can incorporate into AOA diagram, or then AON and PDM diagram. This is the same concept anyway. So I do not want to repeat. Total float and free float, also the same concept. Except that when we start putting into the AON and PDM diagram, you would be able to see how basically we do the calculation. Okay, we do the calculation. How do we do calculation? Again, forward pass. The same concept as before, because the forward pass, backward pass is the CPM calculation method. It does not uniquely belong to PDM or AON or AOA, no. It is basically the critical path method concept. So forward pass is for us to get the early start value. So basically we start with the zero duration at the beginning of the diagram anyway. And then when we add with D, we are going to get early finish. This is early finish. So we start with the early start. And then after we do the forward pass, you notice at the end of the day, we are going to get the overall project duration. And subsequently, actually, we can calculate the free float already. Except that when we construct using the AOA diagram, it was a little bit difficult for the free float because the value that we input into the node or the whatever the box that we create, we choose between the bigger value and then we hide the value that belong to each of the activity or the task. But now in AON or PDM, all the values basically is being shown on that particular box. Now everything become very transparent, so we can get the free float value very, very fast. Backward fast method in order to calculate late start and late finish. So how do we get late start? Late start is by deducting late finish with the duration. Okay, that will be the backward calculation. And then after we complete all the values, we can calculate the total float. We can use the formula that I always teach you, or there is a simplified formula for AON or PDM diagram. Okay. And at the end of the day, we are going to indicate or understand which are the critical activities. The critical activities when the total float is equivalent to 0, and when critical activities are connected together, they form what we call critical path. Okay. So this is a typical what we call AON diagram, okay, or PDM diagram, whereby you notice that each of the activity is being put inside the node. The node now we draw in a box instead of circle, in order to avoid confusion with the arrow diagram. So this is the activity we put inside the box. Start and finish. Start and finish is one type of activity that we call it milestone activity. Milestone activity that we add, okay, that we just simply add into the diagram to looks good, okay, because sometimes in this particular diagram, we know already A and D are the two starting activities. But if, for instance, we do not add the start milestone activity, then A and D basically hanging together like that, well, it is not wrong, okay, to draw the network diagram like this. But as we mentioned, the concept of network diagram, we want to connect everything together. So we might want to add the start and then finish activity. You notice that C and F are the finishing activities, but we do not know which one basically will finish later. the one that finished letter will indicate that is the project completion period. Okay, it will be locked, okay. But then in order to make it look nicer, we just simply add finishing milestone. And finishing, starting and finishing milestone do not have duration. It basically do have zero duration. Zero duration. This is another example of activity that have zero duration. Another type of activity, remember, the dummy activity also have zero duration. But dummy activity we use in arrow diagram only, whereas the start milestone and finish milestone we normally use in a PDM diagram, okay, in order to properly connected all the activity in network diagram, so that we do not have the activity that hang either at the beginning or at the ending. Okay, again, normally when we want to construct a diagram, we need to come up with the listing of activity or tasks. Okay, here we normally list task name, start and finish, and then we do have A, B, C, whatever it is, and then duration. We put into proper unit, maybe days, for instance, and then predecessor or successor. We can use either one, but by default, predecessor is widely used, okay? And task ID, this is what we call task ID. In Microsoft Project or Primavera, the way to connect the predecessor is not by the name, We are going to connect using this ID numbering. This ID numbering is going to be auto-generated in the software. So how basically software will the software format in terms of predecessor, it will look like this. Start is basically ID number 1, so 1. A is ID number 2, so 2. B is ID number 3, 3. C and H, C is 4, H is 9. And then start again is 1. This is how basically predecessor in the computer program looks like. We do not use this kind of what we call labeling, okay? But in our class, most of the time, we just simply simplify things. We use this concept instead of ID. Later on, when we learn about Microsoft Project, you will realize we are not going to use predecessor by name labeling. Instead, we are going to use ID labeling based on the things being generated by the computer anyway. Okay, now, once we do have this, what we call information, now we can start to construct the diagram. How do we construct? Of course, we are going to, the easiest way, if you have no ideas, you just remember, you just count how many boxes that you need to have in the diagram so that you do not miss. Okay, you have 10 boxes, 1 until 10. Okay, you have 10 boxes. So you will draw the box, start. And you know that at the end of the day, this is the finish. Okay, so now you already have these 2 boxes for this one and this one. Okay, now you are going to go down the list. A, this A is going to be connected from start. So just put A here and connect from start. Now you already completed the second box from the left until right. And then B is connected from A. So A is already here. just draw another box B and then connect. So you go down the list. Never mind if, for instance, the drawing might not look nice at the beginning, but at the end of the day, once you connect all the activities, then only you see, oh, okay, this is how the drawing looks like, and you can double check by going the reverse from the finishing, and then you connect with what. That is the way. So you cannot get the drawing wrong. Once you get the drawing wrong, then the whole calculation will be wrong. Okay. So how to draw, I will advise you. Please identify how many boxes. You know already there are 10 boxes that you need to have in your diagram, because sometimes, for whatever reason, when people draw, they might basically miss out certain activities. So be careful. Okay, so you cannot go wrong, and you can crisscross the arrow. In arrow diagram, in AON or PDM diagram, you can crisscross the arrow, because arrow just indicate relationship. Because sometimes people are so afraid to crisscross the arrow. Okay, because you must remember, or you must distinguish between arrow diagram and then AON or PDM diagram. Arrow diagram is different. Arrow diagram, the arrow itself represent an activities. Whereas in AON or PDM, arrow is just simply represent relationship. So once basically you connect one activity with another, that's it. You fulfill the relationship already. So forget about the arrow is being crease and cross. Later on, we do have an example, the arrow that crisscross, for instance. Okay, so in this diagram, it looks nice because we already come up with the what we call draft, and then we arrange the activity together. So it looks nice. But for instance, for the first time that you draw, you might basically put a certain activity in the wrong place anyway. But once, if for instance, you have the connection right, so meaning to say your diagram basically right. It just not to say it is wrong. Even though your position of G could be here, you might put G here. So G is connected from E, okay. And G also connected from and the D up here, for instance. So there is nothing wrong with that, okay. You can draw something like that. Okay, now let's say this is the drawing. And remember, each box do have early start, early finish, late start, late finish value to be filled in. And there is another slot. Normally, in this particular slot, we can put TF or FF. What does TF stand for? TF stand for total float, and FF stand for free float. Yeah, you can, because the box do have many compartments, so you can put all the values there. All right, now we fill up the values with the early forward pass and backward pass. Okay, let's go ahead with the forward pass. Okay, remember the start and finish also do have the early start and early finish, late start and late finish values. So what is the starting point here? 0. And the duration is also 0. 0 plus 0 equivalent to 0. That is basically the starting point of the start activities or tasks. So this 0 will be transferred here, and this 0 will be transferred into A and E activities. So if, for instance, you do not want to put the start and finish activity, it is okay, because at the end of the day, these are the value that we want for A and E, okay? The value already in the box. But again, if you do add start and finish activities, automatically they will have the values of 0, plus 0, plus 0, and this 0 basically you transfer into here and then here. Okay, now we start with A, 0. 0 then plus the duration, remember? Forward pass is all the addition of duration, but happening within the box. So 0 plus 7 equivalent to 7. So now we already completed activity A. Okay. A and B. A and B do have relationship finish to start. So meaning to say this 7 will be transferred into this box immediately. Okay. So that's how 7 get into B anyway. And then within the box, you are going to add with D, 7 plus 6 equivalent to 13. Then transfer into subsequent C, because C do have finish to start relationship. 13 plus 3 equivalent to 16. Okay, now we already completed A, B, and C. So we solve these, the bottom of the task first, because you notice that here, this activity do have 2 arrow coming in. So meaning to say this value will be determined from whichever bigger value from the concept of forward pass. Remember? Okay. For E, we start with 0. 0 plus 3 equivalent to 3. And 3 will be transferred here. And 3 will also be transferred here, because it is finished to start relationship. So again, within the box for F, 3 plus 3 equivalent to 6. And then for G, 3 plus 2 equivalent to 5. Then there are 2 arrows going into this box. You see, you notice there are 2 arrows coming in here and here. And since it is the forward pass, you read this note here. You read this note. It mentioned in forward pass, we are going to choose the bigger value, because the concept of activity H can only be started after both F and G completed. G will be completed on day number 5, whereas F will be completed on day number 6. So this 6 will go into this box, the bigger value. And then within the box, you just simply add with duration, 6 plus 2 equivalent to 8. And now we do have this value, 6 or 8, that goes into D. And of course, we are going to choose the bigger value from C, 16. 16 will be here, and you need to solve the within the box. There are students who will get confused later on, because they still get confused with arrow diagram. They just stop here at 16, and 16 is the final answer for the overall project duration. No. You need to add with the duration in order to get into this box. This is the right answer. Okay. There are people who get confused because of transition between arrow diagram and AON and PDM, but you need to practice anyway. So that's why we design your assignment number 1, that we already incorporated question from the previous test and previous final exam. If you practice or you do your assignment well, you should be able to get the concept right, okay? And eventually you should be able to answer the test and final exam question anyway, because everything is there already. Okay, 16 plus 4 equivalent to 20. 20 is the answer, the overall project completion. So now we already completed the forward pass. Remember, forward pass basically answer early start, early finish, overall project duration, and even the free float. Even the free float. But we reserve the free float and total float toward the end, okay? As we do not want you to get confused. Now let's complete the diagram with the backward pass here. Backward pass, okay? We already have this value from the forward pass. So this value will be transferred into this box. Actually, if we do have finished what we call task, this 20 actually will be transferred here. 20 and duration is 0. 20 plus 0, 0 equivalent to 20. So basically this 20 is the last day of the project. Okay. So this 20 will be transferred inside here. This is 20, and 20 minus 10 will be 20. Okay, but actually, whatever it is, this 20 is coming from here, the last day of the project. So that's why this 20 is basically is here. Actually, it is being transferred from the finish of the finish milestone activity 20. Okay, so 20 will be there. So 20 will be the late finish. And how to get the late start? So use this formula. Within the box, we are going to deduct LF minus 4 equivalent to 16. Okay, so we already complete the values. And this 16, then we are going to transfer back into the box that have the arrow coming in. So that's why 16 is going to be locked here in this box. And then within the box, you are going to minus with the duration that belong to such activity. For C, for instance, 16 minus 3 equivalent to 13. Then transfer into B, 13. Then within the box, 13 minus 6 equivalent to 7. And then transfer this value into this A, 7 minus 7 equivalent to 0. Okay, now we already completed A, B, C. Now let's go into H. H, we already have 16 here. Within the box, 16 minus 2 equivalent to 14. And then this 14 will be transferred into two boxes because there are two relationships that connect between them. Okay, so this 14 will be in F and this 14 will be in G as well. For F, 14 minus 3 equivalent to 11. All right, so we finish on F. And then for G, 14 minus 2 equivalent to 12. Okay, within the box. But then when we go into E, this 11, where do this 11 come from? From the previous activity. Okay, remember, E do connect, do have connection with F and G as well. When we go back using the backward pass line, we are going to choose the smaller. Read this note. Read this note. So that's why 11 will be here, and 11 minus 3 equivalent to 8. Okay, now we already have a date for early start, early finish, late start, late finish. Okay, so meaning to say from the early start, early finish, late start, late finish value, we know that certain activities do have variation in terms of the early start and late start. Whereas certain activity do not have the variation. Meaning to say A, you notice A, B, C, and even D, they do have the same starting date and they do have the same ending date, and then late start date and late finish date. So from that, you might have some ideas what kind of activities they are being categorized in. Okay, from that concept alone. But then, let's forget about that. Let's say we want to complete the calculation doing what? Item number 3 here, the step. This one. We can calculate total float. And then we can calculate the free float. Okay, now, let's go back to this diagram. Concept diagram first. Okay, now, calculating total float using this formula. For AON and PDM, you can use this formula. It will always work. Why? Because in that particular box, all those values belong to that activities. It is not being shared. So you can use this formula, or you can use even the same formula that I told you before. Total float equivalent to late finish minus early start minus duration. But it will take a longer period to calculate using this. For instance, let's go for D. For D, for instance, late finish is here, 20, 20. Early start is 16, 16. What is the duration for D? 4. And you do the calculation, of course, you will get 0. Okay, you still get the total float, but it is faster to use this formula. What does this formula mean? You can use the differences between this value, either on the late start minus early start, or late finish minus early finish. For instance, 20 minus 20, of course, equivalent to 0. Or 16 minus 16, of course, it is going to be equivalent to 0. So that is how total float is being calculated. Faster in AON or PDM. Okay? All right. So you can use this formula. For instance, for activity H, you see, 16 minus 8, you will get 8. Or 14 minus 6, you also will get 8. Cannot be, you get different values unless you make a mistake in putting the values. Cannot be. It must be the same. Either you take the calculation of late start minus early start, or late finish minus early finish. You must have only one value. If you have different value, when you say somewhere along your copy and paste the value, it might be wrong. So please double check your answer. Okay. So now we use this formula and we get all the total float. See the total float value. The total float value. And remember, when activity have total float value 0, meaning to say that activity is being considered as critical activity. When those critical activity are connected together, they are being called critical path. See, critical paths from A, B, C, and D. A, B, C, and D. Start and finish, they are not even part of the activity anyway. But sometimes when you put into the drawing, computer, for instance, of course, they will indicate this activity in red. So the critical path will be going into this line. So that is the thing. But the real critical activity, they appear on the listing A, B, C, and D. All right. So now, one more thing. Total free float. Okay, this is the issue. Free float. Free float. Free float. How do we define free float again? Free float is the gap in between activities. So meaning to say, you need to find activity which are connected together. And it is not only one in one line. So meaning to say that activity must have multiple activity connected into such activity. And then only you will notice there could be free float in one of the activity, whereas another one could have a free float of 0. Okay, for instance, between B and C, let's say I want to calculate the free float of activity B. The formula is being defined like this. Take the early start of the subsequent activity, which is C, minus the finishing of B, early finish of B. That is the formula. So in such a way, in order to calculate the free float, you must have the two activity connected together. Then only you can do that, okay? But in this particular case, you know already the answer. The early start of C here, 13. The early finish of B is also 13 because they are coming from the same line. 13 minus 13 equivalent to 0. So that's why when there are two activities connected together, the only activity connected together is only two, the previous one and the successor. You know that free flow is going to be 0. So actually you don't have to bother. The only thing that you can bother is this concept. You look at this activity, and there are two activities connected, for instance, here. Then you know, C and D. C and D, there is no free float because they are critical activities and free float will be zero as well. But then between H and D, okay, now let's calculate free float for activity H from the formula. If you want to use formula, I do not use formula because from the diagram you can notice very quickly. Okay, early start of the subsequent activity D minus the finish of H itself, which is early start of D is 16 and early finish of H is 8. So the free float is 8. And the free float 8 is what? What does this thing mean? Is the gap in between. The gap in between finishing of such activity and the starting of the subsequent activity. That's why I always mention to you, in order to figure out about free float, so you need to find this kind of condition first. And not all the activity do have this condition, only a few. So in such a way, free float is very easy to calculate. You know that some of the activity do not have any free float. Only when this kind of situation, for instance here, this is the situation whereby you know that there is a gap in between H and D. Okay, now let's go into this another situation here. Another situation here. Okay, there are two activities connected into H, F and G. You can use the same concept between F and H. Here, you just compare this value, these two values. Between these two values, there is a zero gap. So you know that the task F will have free float of 0. You see, you don't have to use this formula. You just simply compare those value, and the good thing is that AON or PDM diagram, all the value are in the box. So you don't have to crack your head or basically figure out what could be the early finish of the previous activities, which in arrow diagram, we do not basically jot down, for instance, unless you put a note there, then it is okay. Okay, how about between G and H? You notice this value. You can compare between this value, then you know free float for G equivalent to 1 because there is a gap in between the finishing of G and the starting of H by 1 day. So meaning to say G can be delayed. Delay meaning to say if G require more time instead of 2 days, the maximum additional day is basically 1 more days. And let's say if G is extended by 1 more days, still the starting of H will go on as usual on day number 6, and there is nothing, they will not impact the H, for instance. Okay, they will not impact H, but still H do have a lot of free float more. Okay, anyway, but the issue with regard to the free float is the definition. Definition is basically the free time such activity have without affecting the starting of the subsequent activity. Subsequent activity here between G and H is this issue, the starting. Okay, now E and F, you don't have to basically bother. Why? Because from the diagram, you already know. If you compare this value, 3 and 3, you know that free float is basically 0. Okay, so you don't have to bother. So now you already know, in this diagram, the only activities that have free float values is H and then G. The rest basically do have free float value of 0. Okay. Okay, now let's go into another example. By right, once we give this kind of information, you should basically start with the drawing. Activity A, you know that there are 5 box A. Okay, A is the starting activities. And then B, and then B is connected from A. And then how about C? Oh, C is also connected from A. So you can draw something like this. And then D is connected from D is connected from C. Here, this is D. And then E is connected from, we put it a little bit far away so that we can erase. This is the example of, okay, E here. Why? Because E is connected from D and then connected from B. You see, this is how we draw, going down the list. And you notice there are 5 boxes, and you cannot get wrong, okay? Even though when you draw, it might not look nice, but once you have the connection right, so meaning to say your drawing could be right, okay? Then you input the duration and then go with the calculation, okay? This is example of inputting the start and finish milestone, even though it is not necessary. Why? Because whatever it is, this 0 will basically the same thing for A, we start with 0. Where do we get the 0 from? If we do have milestone activity, 0 plus 0 equivalent to 0, and 0 will be transferred here, which is not necessary anyway because this is such a small project. But if we want to do that, so do it properly. Okay, this is how to do. So start from 0, 0 plus 4 equivalent to 4. Then 4 transfer here, 4 plus 3 equivalent to 7. And then for C, 4 plus 2 equivalent to 6. Then 6 will be transferred here, 6 plus 5 equivalent to 11. And then between 11 and 7, which one is bigger value? Of course, 11. So 11 will be here. 11 plus 2 equivalent to 13. So basically, project will be completed on 13 days. Okay. So now we know already project completion date is on the 13 days, week, depend on the dimension anyway. Okay, now backward pass. So once we get this value, we can copy into this box. Okay. 13 within the box minus with duration, 13 minus 2 equivalent to 11. And then transfer here. And also transfer into B because they are connecting arrow there. And then within the box for B, 11 minus 3 equivalent to 8. Within the box for D, 11 minus 5 equivalent to 6. 6 transfer here. 6 minus 3 equivalent to 4. Now, you see, you notice there are 2 arrows coming back here. There are 2 arrows coming back, and for backward pass, we are going to use the smaller, okay, smaller value. So 4 will be chosen. 4 minus 4 equivalent to 0. Now, you see, we start with 0. Then we are going to go back with 0. If along the way, you might not have the value, so meaning to say you might do the calculation wrong somewhere, so please double check. Okay, this is the, what is this? The total float, etc. We can calculate total float very quickly. Okay, very quickly, we can calculate total float and free float here. This is the legend. Okay, for instance, for B, how do we calculate total float? 11 minus 7. 11 minus 7 or 8 minus 4 equivalent to 4. This is the total float, TF. And how about the free float? Okay, for the free float, we need to compare with the subsequent activity. B connected into E. Now you see, this value, we can compare with this value. So you see, 11 minus 7, we get 4. This is what we call free float. Because the value are there in the box, we can easily calculate the free float. And if you compare between D and E, see, the value are the same. The free float is 0. Between C and course, the same here, 0. Between A and B and A and C, also the same. Okay, so free float is 0. So the only activity with the free float is basically B. And the only activity with the non-critical activity is B. The rest are basically the critical. So the critical path is here. This is the critical path. A, C, D, and E. Those are the critical activities, and the critical path is A, C, D, E. All right. Okay, and now it is a more complex figure. Whatever the complexity of the figure, the concept is always same: forward pass and backward pass. So we start with 0, 0 plus 0 equals 0, 0 here, 0 here, 0 plus 3 for A, 0 plus 3 for D, and then for A, transfer into B and C, 3 plus 2 equivalent to 5, for C, 3 plus 5 equivalent to 8, and then for D into F, transfer 3 plus 5 equivalent to 8, and then you notice B and C will go into E, the bigger value will be 8 here, so 8 will be here, 8 plus 4 equivalent to 12, and then E and D going into G. The bigger value is 12 here. So 12 will be here, 12 plus 6 equivalent to 18. And then 18 will go into H, for instance. Okay, will go into H. And then 18 plus 21. And then there are two activities going into the finish, H and F, from the information given. But whatever it is, the finishing is basically taking from the longest duration in that basically path, which is 21. Okay, so 21 will be transferred into the finish box if you have, but you already know this is the overall project duration. And you notice that when we do the backward path, we are going to log this 21 here. 21 plus 0, 21, 21, and 21. And 21 will be transferred here. Notice, and this 21 will be transferred here as well. And this will be the late finish of whatever activities. So that's why we mentioned certain activity to have some late start and late finish, whereas critical activities normally do not have the different late start values, because the early start and late start will be the same. Okay. All right. This is another easy AON diagram. We can complete this one very easily. 0. 0 plus 2 equivalent to 2. 2 transfer here, and 2 transfer for C. And within the box, 2 plus 6 equivalent to 8. C, 2 plus 3 equivalent to 5. And for B into E, this is 8. 8 plus 6 equivalent to 14. Okay. For D, 8 plus 1 equivalent to 9. And then for F, between 9 and 5, of course 9 is bigger. 9 plus 3 equivalent to 12. Okay. And then between F and E, the bigger value will be coming from E. 14, 14 plus 2 equivalent to 16. You see? So the project basically finished on the 16 days. Then you copy back 16 minus 2 equivalent to 14. 14 transfer here and 14 transfer here. And for E, of course, it will go back to the same things, because you know already which one is the critical path or the critical activities. For F, 14 minus 9 will be 5, for instance. Oh, sorry, minus 3. Okay, minus 3, not 9. 11. And then 11 will be here, and then 11 will be here. 11 minus 1 will be 10, and then 11 minus 3 will be 8. Okay. And then between 10 and 8, 8 will be here. 8 minus 6 equivalent to 2. And between 2 and 8, of course, 2 will be the smallest. 2 minus 2 equivalent to 0. So that's how you complete the diagram. So once you complete the diagram, how to calculate total float? Very easy. Using total float equivalent to late finish minus early finish, or late start minus early start. Okay, for instance, 14 minus 12 equivalent to 2. That is the total float. Or for D, 11 minus 9 equivalent to 2, or 10 minus 8 equivalent to 2. For A, B, E, and G, you notice that they are the same values there. You know already. When you subtract this value, you are going to get 0. So these are the total float. 0, 0, 0. So those are the critical activities and the critical path. Okay, now we go into the free float. Free float again. Remember, the concept of free float is in between. In between. But you know which one to basically focus. Okay? You can find multiple activity going into the subsequent activity. Then you notice that free float will be in one of the activity, whereas another activity will not have the free float. For instance, this box. There are two activity going in, E and F. E and F. So E and G, E and G, basically, if you compare this value, the free float will be 0. Okay. And for F and G, if you compare between this value, 14 and 12, you will get 2. So that is the free float. Okay. Free float, I basically note down in on the arrow, which is by right we should put into the box, but since I do not have the slot in the box, I put it there. So you just simply compare. Another way to compare here, D and F, C and F. You know, between D and F, you compare this value, of course free float is 0. You compare between C and F, 9 and 5, of course you get free float of 4. So you see, only selected what we call tasks or activity do have free float values. The rest basically do not have. The one which basically fall on critical path, there is no free float values, so you don't have to calculate. They are the ones you are going to waste your time. Okay, this is another example. Instead of giving the information using the predecessor, the information given is based on successor. This is another way of giving the information. Okay, whatever it is, you need to basically draw the diagram. Okay, for instance, you start with A. You start with A. After A, there are two activities, B and D. B and D, then you connect them together. This is what successor is all about. Okay, but then you need to be careful with the type of relationship. A and B is finished to start. A and D start to start. This is wrong really. The way to draw, you need to draw something like this. Then only it becomes start to start. When you notice the relationship do have variation than finish to start, then you know already this is not a typical AON diagram. It is being classified as PDM. Why? Because it do have different type of relationship other than finish to start, and it also have lag. Two places with lag. Okay. So first thing first, draw the diagram and look at the type of relationship that you need to be very careful, and look at whether there is a lag, a lead being indicated there, and then only you are going to have the right basically diagram. Okay. So again, this diagram we have shown you before. So we start with 0, 0 plus 2 equivalent to 2, 2 transfer here, 2 plus 2 equivalent to 4. I see, this is the lag. The proper way to indicate or label is like this, Fs plus 1. But sometimes in the drawing, we just simply put whatever the labeling. So basically, automatically, if the arrow is, you draw it correctly, so meaning to say this indicate finish to start, okay? And then the way to basically do the calculation to incorporate the type relationship. But before we go into the C, let's go into the D first, because this box will be influenced by two arrow coming in. Okay, let's solve the D. Okay, D basically do have start to start plus 1 relationship. So whatever it is, 0 here will be transferred along the line, but incorporate 1. Why? Because forward pass mean 0 plus 1. Because remember, a lag can be negative as well. If it is negative, then there will be different way of doing it. Okay, you need to basically incorporate that. But since we start with 0, normally we are not going to have a negative value there. Okay, so 0 plus 1 equivalent to 1, 1 plus 1 equivalent to 2. Then transfer here, 2, 2 plus 1 equivalent to 3. And 3 and 4, of course, the bigger value will be 4, but instead of transfer into here 4 directly, but we need to take into account plus 1. So 4 plus 1 equivalent to 5. So 5 will be here. So 5 plus 1 equivalent to 6. Okay, so the project completion is on the 6 days. Then we copy the 6 into here, then do the calculation within the box and inter box. 6 plus minus 1 equivalent to 5, and then 5 transfer here. 5 minus 1 equivalent to 4, and then 5 transfer here, but when we do the backward pass, we need to minus 5 minus positive 1. 5 minus positive 1 means this is 5 minus 1 equivalent to 4. And now you see, that's why PDM diagram is chosen technique in many of the software, because it basically can incorporate lag, lead, and different type of relationship automatically. It will reflect the timing, the right timing that we want in our schedule. Okay, 4 minus 2 for B, 4 minus 2 equal to 2. And then you notice that in this diagram, there are 2 arrows coming back. Okay, how to resolve this thing? Let me show you. There are 2 ways to resolve. 2, if it is coming from this line, so 2 will be here. If 2 will be here, 2 minus 2 equivalent to 0. That is correct as one alternative. But you have to be careful, because in some other example, the right answer might not be coming from this line. The right answer could be coming from the bottom of the line, or a different arrow coming back. So we need to be very careful. So, but in this particular diagram, for instance, 3 will be coming back into this line, but 3 will be minus with the lag. 3 minus positive 1 equivalent to 2. 2 actually will be inside this box value. And once it is there, 2 is here, how do we get this value? 2 plus 2 equivalent to 4. And you notice that between 2 and 4, which one is the lower value? 2 is the lower value. So that's why 2 is going to be locked inside this box. And this 2 is basically coming from B, actually, from the line B. So meaning to say, when this situation exists, actually, it basically reflects which activity or which relationship is more dominant. In this case, for instance, the one that dominate is coming from B instead of D, for instance. Okay. All right. You notice in this diagram, there is a dotted line here that indicate total float values. Okay, total float value for E, 5 minus 3, 2. 2 is the total float value. 2 weeks, because we use the week. And total float value for D, 4 minus 2 equivalent to 2. The rest basically doesn't have the total float. Okay. And how about the free float? Free float, we can notice that between this is very classic example. Very classic example. If you are not being careful, you might make a mistake. Okay, I already mentioned to you, in order to indicate free float, you just need to know which activity, more than one activity that goes into the subsequent activity. For instance, what goes into C? There are two activities, B and E, for sure, from this diagram. And if you notice this value here for E, 5 and 3, automatically you know that the free float for E is equivalent to 2 weeks. Clear cut. But how about here between B and C? You notice if you do not consider the lag, you just simply minus this value, 5 minus 4, you thought that the free float for B will be 1. That is the wrong answer. You need to consider here. This is what makes the PDM diagram a little bit complex. But whatever complexity, you must remember the concept. Where do these 5 coming from? It's from the addition of 1, isn't it? So when you want to make comparison, what you need to do is like this. 5, okay, 5, you need to subtract with plus 1, you are going to get 4. Okay, then you minus with this 4. You notice? This 4 and minus this 4, then only you are going to get 0. So the free float of B should be 0. Okay, should be 0. But if, for instance, you just simply take this value, compare this value, it's not going to be accurate because you fail to take into account the lag or lead into the consideration. So in conclusion, for the free float, even though we know that there is we can take the gap in between, but if you use the formula that I gave you before, this formula, okay, this straightforward formula, you are going to get confused. You are going to get confused when dealing with what we call different type of relationship, and lag and lead. Okay, never mind. We are going to demonstrate those things later on. So you need to be very careful. Okay. Okay, this is normally in the physical class, we are going to give you this exercise and let everybody try those things. Then only you are going to see the issues. Okay, what kind of issues you are going to deal with? You are going to see the issues of crossing arrow, like what I did. You see, this one, for instance, a few arrow that basically cross here, cross. And people are so afraid when they have this kind of situation. But don't worry, in AON or PDM diagram, you are going to get those kind of things. Okay. And in this situation, arrow simply mean the relationship. The most important thing, for instance, between B and C here, B basically goes inside here. And of course, it will cross the other arrow, but it doesn't matter. It does not mean anything other than reflecting the relationship. So you are not going to change whatever the situation. Maybe you are going to get confused with arrow diagram. Arrow diagram, yes. Arrow itself reflect activities. But in this situation, arrow simply mean relationship. The most important things from this kind of listing, you are going to start uh, connecting the activities together. Okay, even though the activity are not a lot, A until F, but the complexity in terms of some of the arrow that you need to cross. It is okay to have crisscross arrow in PDM or AON diagram. Similarly, this looks more complex. We do have more activities. Okay. In the final exam, don't worry, we are not going to give you more than 20s, but it is more than 10 for sure. More than 10, less than 20. Okay. In this situation also, you notice that we do have uh, only one, okay, one relationship here that crisscross. I normally draw like this in order to indicate the F is basically connected into H there, okay. The rest of the activity do not have the crisscross line anyway. Okay, so that would be the 12A. Okay, let me close this thing first.